Have you ever stopped to think about how a company the size of LinkedIn manages to secure its code? I mean, we're talking thousands and thousands of projects all at once. Well, we're about to break down their incredible solution for what's called static application security testing, or SAST. And let me tell you, it is an absolute masterclass in tackling enormous scale with some seriously clever engineering.
So let's just let that number sink in for a second. We're talking 10,000 plus software repositories. And no, that's not a typo. Every single one is its own little world, right? With its own team, its own code, its own history. So the question becomes, how on earth do you create one single security process to cover all of that without just bringing development to a grinding halt? I mean, that's the massive mountain LinkedIn was staring up at.
All right, so here's how we're going to walk through their story. First, we'll dig into the scaling problem they were up against. Then, we'll look at the core principles that shaped their new design. After that, we'll see the actual pipeline they built, the huge roadblock that nearly derailed the whole thing, and the brilliant stub workflow that came to the rescue. And finally, we'll see the impact it all had.
So what did things look like before this big project? Well, to be totally honest, security scanning at LinkedIn was kind of messy. You can think of it like this big, fragmented ecosystem, where getting any kind of consistency was basically a pipe dream. And that, as you can imagine, created some major headaches for everybody.
This slide really just lays it all out, doesn't it? The old way was a total patchwork of different scanners. And what does that get you? Inconsistent security, super slow feedback for the developers trying to get work done, and for the security team, almost no visibility into what was going on. The goal was the polar opposite, one single, unified pipeline that could actually enforce scans, give developers fast, useful feedback right in their pull requests, and make the entire process totally transparent.
So, to pull this off, they knew they couldn't just throw a new tool at the problem. No, this required a whole philosophical shift. It's all about shifting security left, which just means embedding it way earlier in the development process. But, and this is the important part, they had to do it in a way that developers would actually get on board with. And it was all built on these 4 core ideas.
Okay, these 4 pillars were basically their constitution for the project. First and foremost, developer-first security. Why? Because if it slows developers down or gets in their way, they're just not going to use it. Simple as that. Second, extensibility, making it easy for other teams to plug in their own custom security rules. Third, resilience, because a scanner that's failing should never, ever block a developer from shipping code. And last but not least, observability, so they could finally get a clear, high-level view of security across the whole company.
Okay, so with those principles as their North Star, they actually started building the thing. Let's take a look at the technology they picked for their brand new security toolkit.
So the engine driving this whole operation was GitHub Actions. For the scanning itself, they went with a pretty powerful combo. CodeQL, which does this really deep compiler-level analysis, and Semgrep, which is known for being super fast and flexible. Now, to make sense of the results from both, they standardized everything into something called the SARIF format. And here's where that developer-first idea really shines. They enriched all of these reports with custom info, giving developers crystal clear, step-by-step instructions on exactly how to fix any issues, no more guesswork. All right, so the tech is picked out, the guiding principles are set, the whole plan looks rock solid. But then, as they start to roll it out, they hit a wall, a massive, totally unexpected roadblock that pretty much threatened to shut the whole project down.
And here's the problem in a nutshell. To use GitHub Actions, you need a special workflow file inside every single one of those 10,000 plus repositories. So what happens when you need to update a security rule or tweak the scanner? Are you really going to create and merge 10,000 separate pull requests? I mean, it's not just a pain, it's a logistical impossibility, a total nightmare.
So, staring down this scaling nightmare, the team came up with a solution that was just so clever, so elegant. They called it the stub workflow, and it was a total game changer for managing all of this centrally.
So what is this stub workflow? What's the big idea? Well, just picture this. In every single one of those thousands of repos, you place this tiny, super lightweight file, and its only job, literally, its only job is to act like a signpost. It just points to one single central master workflow where all the real work, all the heavy lifting, actually happens. It's kind of like, instead of putting a giant engine in every single car on the lot, you just give each car a key that starts one massive superpowered engine back at the main office. It's a genius move in delegation.
Let's walk through how this works. Step 1, a developer pushes some code. This automatically triggers that little local stub workflow.
Step 2. That stub immediately does its one job. It delegates. It calls the central workflow. Step 3. The big central workflow does all the heavy scanning and analysis. And Step 4. This is the magic. When the security team needs to make an update, they edit one single file in that central location, and the change instantly applies to all 10,000 plus repos. Just like that. Problem solved.
Of course, they also built in some crucial safety nets to make sure the whole thing was resilient. They've got a drift management system that constantly checks to make sure no repository stub file gets out of sync. They built in kill switches to pause scanning if there's ever an outage. And, sticking to that developer-first rule, if a scanner ever fails, an automated fallback kicks in to make sure developers are never blocked. This system wasn't just smart, it was built to be safe and reliable.
So, after all that work, what was the final result? Well, they ended up with a truly unified system that actually delivered on everything they set out to do.
I don't think I can say it any better than the LinkedIn engineers themselves. They said, "We moved from a fragmented ecosystem to a unified GitHub-native security pipeline that provides consistent coverage and actionable feedback without slowing developers down." I mean, that's the holy grail, right? That's the dream.
And it's really important to remember the bigger picture here. This incredibly powerful SAST pipeline isn't an island. It's one critical piece of LinkedIn's much larger defense strategy, working right alongside other tools that scan for things like vulnerable dependencies and accidentally exposed secrets. It all works together to create a really comprehensive security shield.
And that pretty much brings us to the end. The story of LinkedIn's SAST pipeline is just a fantastic case study in how you can solve huge problems at scale by centralizing the complicated stuff. Which kind of leaves us with one final thought to chew on. What's one central process in your own work, in your own team, that you could simplify today?